what I'll do is I'll try to take you through the journey of learnings that Armstrong's had over the last several years, 20 years. It's a long journey with a lot of learning, so I'm hoping that I can do justice to it in the next 15 minutes. But please stay with me because there is a lot that we've learned and which we'd like to share with you. There'll be another presentation on this subject tomorrow, but I'll take you through the briefs today. So before we get into discussing our journey, let's understand the magnitude of the problem, or the magnitude of the opportunity in the white space that Peter just defined. There are many factors that lead to loss of energy savings potential in a building, right? We found that majority of the buildings are not commissioned properly, right? That leads to anywhere from 5 to 40% loss in energy savings potential. Also, Peter mentioned about the drift. Drift can be at least 10 to 30% in 1 to 2 years. And that, surprisingly, accounts for close to about $11 billion in wasted energy just in the US. That's a tremendous amount of energy. There is also a possibility of lock-in risks. We're all trying to address this white space. We're upgrading equipment, but we may make a wrong decision. And if that wrong decision happens to be a big one, we have to live with it for a period of time. And research suggests that that loss of energy savings potential could be anywhere from 10 to 400%. That's the cost of making the wrong decisions around energy upgrades. So with that in mind, when we started our journey, we looked at what were people doing. Most of us understand that this is a problem. But what are we doing? Let's look at some of the common practices. Well, energy audits. These are long-term audits that come up with, and what we've found that most of these audits tend to focus on the most energy-hungry equipment in the plant room. Most of them, mostly the chiller, which is consuming the most amount of energy. Let's fix the chiller first. There are partial remedies based on popular solutions, which we'll talk a lot about at this summit. It's the drive on the wall. Hey, you know what? I'll put a drive on the wall. It'll make my pump efficient, then I can target other things. Then there are retro commissioning and recommissioning. I mean, these are designed to bring the building back to its original working conditions, right, or original operating conditions. That doesn't really address the root cause of the problem, right, and not in real time for sure. So that brings us to continuous commissioning. Continuous commissioning, to a large extent, is considered the gold standard, right? Not a lot of people can do continuous commissioning because it's resource intensive, it's expensive. But we're going to say that even continuous commissioning is an audit in time, right? Because it's at a given point in time that you're taking the readings, you're analyzing data, you're coming back and implementing the changes. To us, it's just an audit. Well, there are other problems with continuous commissioning. It's a very centralized process. You need majority of the building owners who venture into continuous commissioning need building automation systems, the building management system that Peter mentioned. It's also based on a lot of monitoring, as I had mentioned earlier, but most importantly, it's based on static rules and human intervention, right? And that actually adds time, and time is something we don't have when we're addressing the drift in the white space that Peter mentioned about. So if we consider continuous commissioning to be the gold standard, then we're not going to have the scale that we need to address this white space energy loss in a short period of time. Okay, so continuous commissioning is not going to fix it. So based on our practice, what we've learned is an ideal system needs to have central control that is strengthened by decentralized and dynamic decision making. Okay. We also learned that the solution needs to be scalable, it has to be in real time, and it has to be affordable. If we are going to make energy, or the white space energy, a target for reduction, we cannot do it if we can't engage a wider population of building owners. Okay? So that, from our experience, would be an ideal solution to addressing the energy challenge in the white space. So when we looked at that ideal solution, we said, okay, where do we start, right? This is a typical HVAC system. Over the period of time, the equipment gets older, it consumes more energy, and it also increases the risk of downtime as equipment gets older, unscheduled downtime as equipment gets older. So we know that upgrades are important to the system, right? But where do we start, right? It's difficult to start, or it's difficult to find a starting point, because most of the equipment tends to drift into islands of functionality. It doesn't work as a system over a period of time. It doesn't work as a system, a coherent system, right? And that makes it even more difficult to understand which equipment to upgrade and what impact it's going to have on the system. So from practice, and Peter talked about this a little bit, we learned that we need to start with the flow, right? Flow is the lifeblood of the HVAC system. And much like the blood that flows through our body, flow tells us a lot about the health of the equipment and the system that it flows in. Okay? It also tells us a lot about the relationship between the building and the white space energy consumption. So with that in mind, we realized that mastery of the flow required mastery of heat transfer. It required us to master demand-based control and digitalization. And we took all those four things and put them in our design envelope technology. And Peter alluded to that earlier. The advantage of design envelope technology, and this is based purely on our learnings in the field, which we've basically developed over the last 18 years, it gives us a system view. So it doesn't look at, when you have design envelope technology in an HVAC system, you're not looking at that system as islands. You're looking at that as a complete system. Okay? It has feed forward, not feedback. Now, this is an important distinction. When we rely on feedback, we're always playing catch up with energy. Okay? We need to be able to predict the energy consumption in the system. And that makes us proactive. And that's what design envelope is based on. It's based on feed forward. It's got built-in redundancy. This, again, taking care of the risk of unscheduled downtime. Design envelope technology, we built that into our technology. And most importantly, it's affordable. As I mentioned earlier, if we are going to address this white space energy challenge on a scale, we need to come up with affordable solutions that everyone can use. Okay? We also learned that as we address this white space energy challenge, trust is the prerequisite. There has to be trust in the community. And trust comes with transparency. And there have been many situations, as we talk to many building owners, there have been many solutions in the past that haven't delivered in time. So there's a lot of skepticism in the market right now. A lot of people are coming up with energy efficiency solutions which 2 years later do not deliver. Okay? So with that in mind, we made sure that we incorporated complete transparency in our new design envelope pumps. Okay? We added connectivity and state-of-the-art analytics platform to this pump. We connected it to Watson. I'm sure most of us are familiar with Watson and what it does in terms of analytics. What this pump does, as you put this pump in the system, it immediately harmonizes those islands of connectivity. And that's because it's based on DE technology. What it also does is it makes the performance of the system and the equipment that it's working with completely transparent through performance management services. Okay? And what is more important is that this pump can provide exact data that any of the building systems, whether it be energy management system or your computerized maintenance systems or your BAS system, all of them can actually get the analytics from this pump. Okay? Completely transparent. Nothing's hidden. It will be any savings that this pump brings about, it is all visible. So when we look at the build-up and when we look at the complete solution to addressing the white space challenge, we've looked at DE, we looked at performance management services. The third thing that sort of completes that solution are automation and optimization solutions. Now, based on practice, we learned that these automation and optimization solutions had to be scalable, and they should be able to integrate into existing building systems. right? They should be open as possible, and not as proprietary, because then the adoption becomes extremely difficult. So our integrated plant control, our integrated plant control systems are completely open, right? They integrate into existing systems, they are scalable, and they learn and can make decisions. And that was an important step in decentralizing decision making to support the central control that Peter talked about earlier today. And when we combine those three characteristics, it gives us something called active performance management. This is a level above continuous commissioning. Now you're making real-time decisions at a decentralized level, supporting the central control in place. Very, very important distinction. Moreover, the system, active performance management, never stops learning. Right? It's always analyzing, it's always learning, which is extremely important, and it's also predicting, which is extremely important in proactively addressing the energy challenge that we have in the white space. So let's look at how we apply this active performance management to the islands of functionality, or the traditional chiller plant that we talked about. Based on experience, we've learned that we start with the heart of the system, and that is the pump. That's the intelligent pump. We start at the pump, then we move to optimization, and then we address the larger equipment like the chillers. And if we take that approach, we keep the entire energy upgrade cycle cash flow positive. And Lex talked about it earlier today. We as Armstrong will guarantee the positivity of that approach. Also, if you look at those numbers, it reduces the cycle of plant upgrade, right? So what this does, it actually helps you make decisions around system upgrade within an OpEx cycle. By the end of the year, you're able to make a decision on the right size of the chiller. Had you made the chiller decision first, it would have costed a lot of capital, which would have made it very difficult for us to upgrade other equipment, because then you have tied up capital and you're waiting for ROI. So in summary, I would say the solution, active performance management, reduces risk. It also gives us approximately 18 lead points if we apply the entire solution. But most importantly, and this is the message that we want to leave you with, is that it keeps energy upgrade cycle cash flow from day one. Okay? With that, I'll hand over the stage to Brent, who will talk about how we've taken these values and learnings and embodied that into all our innovations.